Yeah, so hi all, welcome back. Very good evening to welcome back to the fourth week of TA live sessions for AI KRR. So, can anyone just confirm whether I am audible and is my screen visible? Okay, thanks, Saran. So, yeah, thanks, Balaji. So, yeah, we are going to discuss some questions from week 4 of the course today, which is basically dealing with first order logic. So, without any further ado, let's get started. So, before starting, do you have any specific thing that you would like to discuss from the previous week? If so, maybe we can do that before we start with the questions for today. Okay, so that's fine. Let's get started with the questions for this week. So as I said, we will be discussing some questions from first order logic. So, and these will be a mixture of the kind of questions we have seen till now. Some of them will be recall based questions, some of them will be slightly conceptual questions, and some of them might require you to work out some things and try to answer the question, right? So yeah, this is the first question in front of you. It says the first order logic is a language that talks about a domain or the universe of discourse. So we can refer to the elements in the domain, and which of the following five options do you think would be applicable or correct or relevant in this case? Okay, so we have an answer saying A. So think about it. So I'll give you a hint. This question is kind of on the borderline of being a recall and a conceptual question, right? So think about it in those terms. So remember what exactly is a domain in first order logic, and then think about whether the options will be correct or incorrect or relevant or not. Okay, so now I'll give you another hint. It's not all of them. All of them can't be correct. So, okay, see. So, what is a universe of discourse? Okay, think about it as a superset. Okay, let me actually try to show it diagrammatically. So, consider this big rectangle over here. This is one set. This is your domain. Or you can denote it with U, which is your universe of discourse. Okay, so how will you represent a predicate within this universe or domain? Will it be a subset? Will it be some other set? How will you represent it? Exactly, it will be a subset, right? So for example, let's say this is, can you see the screen that I am drawing on right now? Is can others confirm? if if there's an issue, I can maybe try stopping the sharing and resharing it. Okay, thanks for confirming. Then maybe why don't you try maybe try leaving and rejoining the meeting. Maybe that will solve the issue. Okay, thanks. Okay, yeah, so what I was saying is consider this subset within this domain. Okay, let's say this represents something like man. Okay, so man is a predicate. Now within this there could be different elements, right, that we could represent using a constant. Let's say ram. Okay, so ram is a constant. There we could represent it using a variable x, or we could represent it using a function. Okay, now we can represent an element using a constant, a variable, a function. But can we use a predicate to represent a variable? Can we use a predicate to represent a element? Sorry, not a variable. Now with this in mind, rethink about the options over here. So now which of these do you think could be used to refer to elements in a domain? It will be using constants, variables and functions, right? Because we just discussed that the predicate is a subset, right? It's not one single element, right? It's not referring to a single element of the domain. A predicate is a subset of the domain which contains some of the elements. So the correct answers here would be B, C and D, right? So the first option is not relevant. It doesn't make sense over here. By referring to elements, we do not concern ourselves with maintaining any registry of elements, right? That is just a non-relevant option given to us. And just like we saw, we can represent an element using a constant symbol, using variable symbol and a function, okay, but not using a predicate. So B, C and D are the correct options. Any doubts on this, or should we move on to the next question? Okay, that's great. Thanks for confirming. So this is now question 2 in front of you. Okay, this question says when we define a predicate rich man in our language, L P F P comma F comma C, and we have a sentence rich man Suresh in the knowledge base. What are we asserting? Okay, so when we have a sentence that says rich man Suresh, what exactly are we meaning by this in first order logic? Remain that this concern. Remember that this concerns with the first order logic. Okay, so you may not have to concern yourself with the actual meaning of what these words convey. Okay, okay, we have two options for B. Think a bit more about it, like think about what I just said, right? So this is a logical language, right? First order logic, right? It does not concern itself with the actual meaning, the English language meaning that the words contain. So when you are saying that a predicate is rich man, it does not necessarily mean it refers to a man who is rich. And also remember the definition that we just discussed of a predicate, right, in the previous question. Yeah, that's right, Smarak. Thanks for that. So the predicate rich man over here is just some subset of a domain D. Okay, it does not necessarily refer to all those people who are rich and who are a man, right? It, for all we know, it could refer to something completely different. It could refer to a group of men who are eating something, or who are going somewhere, or anything, any random thing. But it can also refer to a person, to a group of people who are rich and man, but that is not necessary, right? That is what this question is trying to convey. So the correct option would be option D. When we say that there is a sentence rich man Suresh in the knowledge base, we are asserting that rich man is some subset of a domain D. Okay, is that clear? Should we move on to the next question? Yeah, that's perfectly correct, Aryaman. So consider a machine. Okay, that machine doesn't know anything. You just say that rich man is a subset of all the things that it is supposed to know, which is the domain. Okay, now suppose you are assigning the name rich man to that subset. Let's say another friend of yours comes in, he or she doesn't know what name you have assigned to that subset, and they reassign the name and name it rich woman. Okay, you are both referring to the same subset, but you both have named it differently. The machine wouldn't care about it, right? Because it doesn't concern itself with the actual meaning, the English language meaning of that particular subset. Of course, like, we can digress and talk about some really recent developments in more in the deep learning side of AI, where there are transformers, there are these large language models and all that are trained on large amounts of data. Okay, so there you can say that they might have some inkling about what exactly rich and man refer to, but that is not what we are referring to over here. We're not dealing with those kind of complicated deep learning models over here. We're just concerned with a simple logic language, first order logic. So in that case, we are not concerned about the English language meaning. Does that address your question, Aryaman? Okay, thanks for your question. It was a great question. Okay, so shall we move on to the third question then? Okay. So the third question asks us, what is an atomic formula in first order logic? Okay. So remember, we discussed what is a atomic formula in PL or propositional logic in the previous sessions. Now we are concerned with an atomic formula in first order logic. So which of these options do you think would be correct? Okay, so we have one vote for option B by Balaji. So there can be more than one correct option as well. I'm giving you a hint. That's right. A also seems to make sense. What about C and D? That's right. C and D don't make sense, right? So when we are concerned with an atomic formula, we know that it has to be a well-formed formula. Okay, which is basically it has to be in proper syntax and all those things, right? If you can refer back to the lecture slides if you want to see the exact definition of a well-formed formula. And the second option is it is the smallest unit that can have a truth value assigned to it. This is also correct. But when we are concerned with having connectives between two variables, that includes implications and or unary connectives like a not, right? If we have any such thing, we cannot say this is the smallest unit, right? Because if something is connected by connective, we can further break it down into its constituent parts, right? So and an atomic formula cannot have logical connectives. That's a good question, Balaji. Can it have equality? So for that, I would recommend us to revisit the lecture slides. So I will go through these definition once for the sake of clarity, because this is something that we are going to need to answer the next few questions as well. Okay, so let's first see what is a term in LPFC. Okay, for the basic constituents of first order logic, expressions are terms. Okay, and what are terms? If t is something that belongs to variables, then that is a term, If t is a constant, then that is a term. And if we have t1, t2, tn, which is we have n terms, okay, and f is a small f is a n place function symbol, which basically means that if f is a function that takes n terms as its arguments, then that function is also a term. Okay, so this was the definition of a term. Now let's look at the definition of an atomic formula. Okay, so both top and bottom, which is truth and false, they are atomic formulas. If t1 and t2 are terms, okay, then t1 equals to t2. This whole thing is also an atomic formula. Okay, so I think this addresses your question, Balaji, about whether there can be an equality sign. Remember that that equality should be between two terms. Okay. And let's go over the other parts of the definition as well. If we have some n terms, okay, and p is a n place predicate symbol again, which basically means that p is a predicate that takes n terms as its argument, then predicate of those n terms is also an atomic formula. So I think that answers your question, Varun, whether likes Chris. Okay, so remember that when you denote a predicate, it should start with a capital letter, okay, not with a small letter, otherwise it can be confused to be a function. So here what you mean to say likes Chris, if it is a function, which means that this is a function called likes that takes as input a constant which is Chris. Okay, so by definition of a term, this is a term. I mean, likes Chris, this part alone is a term. But likes Chris and something, this has a connective between it, right? This cannot be an atomic formula. Whether it can be a sentence or not, that is debatable. That we'll see in the upcoming few minutes. Okay, so I hope the definition of atomic formula is clear now. Now let's look at what is a formula in general, not just an atomic formula. So if alpha is an atomic formula, then alpha is also a general formula. Of course, makes sense, right? If it is the smallest unit, then it also belongs to the larger set of all formulas, right? Now if alpha is a formula, then negation of that is also a formula. If alpha and beta are two formulas, then alpha and beta is also a formula, alpha or beta is also a formula, and alpha implies beta is also a formula. Okay, so these are formulas. Now let me go to a definition of a sentence. So we have seen what is a term, what is an atomic formula, and what is a formula. Okay, so now when we have a formula of LPFC without any free variables, then that we can call a sentence. No, Balaji, negation cannot have negation. Anything with a negation in it cannot be an atomic formula, right? We just discussed that atomic formula cannot have any connectives within it. Okay, so I hope that will help you, Varun, with your doubt. And now let's get back to the question that we had at hand. Of course, this seems to be answered already. The correct options are A and B, which is that an atomic formula is a well-formed formula and is the smallest unit that can have a truth value assigned to it, and it cannot have all logical connectives. It can also atomic formula having only the unary connective is also incorrect, right? Cannot have any connectives. Okay, so now that we have discussed the definitions of terms, atomic formula, and a sentence, okay, remember in the definition of sentence we discussed what is a free variable, right? So if you have gone through the video lectures, you must be aware of what a free variable is and what a scope of a quantifier is. So this is what this question is based upon: a variable x in a first order logic formula alpha, and which of these options do you think would be correct in this case in context of a variable x in a first order logic formula? Okay, so I'll let you think about this for a while, uh, and then we can have a discussion after a minute or two. Okay, so we have a couple of responses. Now let's look at the answers. So of course, a variable x must necessarily be in the scope of a quantifier if alpha is a sentence of first order logic, right? Because we just saw by the definition of a sentence, it must not contain free variables, and therefore it must necessarily be in the scope of a quantifier if it has to be a sentence. Okay, and of course if it is in the if it is in the scope of a quantifier, it can also be in the scope of multiple quantifiers if it has to be a sentence. A variable cannot be a constant symbol, right? That just makes sense by the meaning of the word variable and a constant, right? Variable cannot be equal to a constant, and it also cannot occur more than once in atomic formula, right? So options A and B would be correct in this case. Okay, shall we move on to the next question then? Okay, thanks Marak. Let's move on to the fifth question then. So all this while we have discussed different things like what is a function, what is a variable, what is a constant, what is a predicate, what is a formula, what is a sentence. Okay, all these things we have discussed till now. Now we have to apply this to answer the following questions. Okay, so here we are given that father and coach are function symbols. Okay, tall with a capital T, this is a relation symbol. Okay, basically means this is a predicate. Sneha is a constant symbol, okay, of LPFC. Now given this, which of the following are sentences of first order logic? Okay, so remember the definition of sentence that we just saw. Okay, a sentence is a formula with no free variables. Okay, so think about whether any of these are a formula and whether they have a free variable. Okay, to decide whether, so there are two parts to this. Okay, first see whether they have a free variable. If they don't have a free variable, well and good, then check whether it is a formula. What is a formula? To check whether it is a formula or not, go back to the definition of a formula. Okay, if that is not sufficient, go back to the definition of an atomic formula. If that is not sufficient, go back to the definition of a term. Okay, and if you follow this recursive way, you will arrive at a conclusion of whether or not this thing is a formula or not, and if it contains or does not contain a free variable. Okay, so I'll let you think about these options for a while, and then we can go through these options one by one. Okay, but try solving these options on your own first, and then we can have a discussion. I'll give you a couple of minutes. Hi all. I see there are a couple of answers in the chat. So I was gone for a while. I had just gone to get some water. So had someone unmuted themselves to ask a doubt in the meanwhile? If so, they can ask again now. I'm sorry for that. Okay, if not, then let's go through the options one by one and see which of them would or would not be correct. Okay, so let's look at the first option. Okay, tall, tall bracket father of x. Okay, so firstly, do you think, does this contain a free variable or not? That's right, x is a free variable, right? It's not within the scope of any quantifier over here, so A cannot be a correct option. Okay, what about option B? Tall father Sneha. Okay, so here Sneha is a constant, father is a function, and tall is a predicate. That's right, B is correct. Why? Because, okay, let's break it down into step by step. So Sneha is a constant, right? And a constant is a term. Okay, and a function containing a constant is also a term. So father Sneha, this is a term. Okay, so father bracket Sneha, this thing is a term. Now tall is a predicate, and we saw that predicate with a term within it, this is a formula, right? So tall father Sneha, this is a formula. Also, this does not contain a free variable. In fact, it does not contain any variable, right? So this is a proper sentence of first order logic. Okay, now what about option C? Yeah, so remember there are two things over here. Okay, father bracket Sneha, this is, father is a function. Okay, tall is a predicate. Yes, it has and symbol, but we are not talking about atomic formulas over here, right? We're talking about a sentence over here. So what do you think? Will it be or will it not be a sentence? It will not be a sentence, right? Because it has two things. Okay, there is an and connecting this part. Okay, tall bracket Sneha, this part is all right, this part is a formula, but this part father Sneha, this is a term. Okay, not a formula, and we know that an and between a term and a formula does not make a formula, right? If we revisit the definition of a formula, for alpha and beta to be a formula, both alpha and beta should be formulas, right? Okay, so we know C is not a sentence. What about option D? So this was option D. For all x, tall father Sneha. What about this one? Okay, but this has a variable, right? Is it free? Is it within the scope? we actually don't need to think too much about it, because the variable x is not even occurring in the rest of the formula. Okay, it is a formula first of all that we can verify, and then this is obviously within scope, but we don't even need to worry about it because it is not occurring again in the formula, right? So we are not even concerned about whether it is within the scope or not. Okay, what about option E? There exists x such as tall father x. What about this? Let's have a look. This is in fact a formula or a sentence, right? Because we have a variable, we have a quantifier, and the variable is also within the scope of the existential quantifier, right? So there exists x, tall father x. This is also a sentence. Now let's quickly go over the rest of the two options. There exists x, father coach x. Again, this is not a sentence because father is a function, right? So this thing, a function of a function, is something that is not defined to us in this particular setting that is given to us. So this doesn't make sense. And the last option, again we have a variable that is in the scope of the quantifier and is a proper formula as well. So option G is also correct. Okay, so are we clear about these options? Difference between A and D. Okay, sure. And option G. Okay, so let's go over A and D. So in option A we had x, which is a free variable. Okay, first of all, there is no quantifier to the left of the formula. Okay, by quantifier I mean either a universal quantifier, that is for all, or there exists quantifier or a existential quantifier, right? So this x over here, this x can take any values, right? Tall father of what, right? It is not limited within the scope of a quantifier. It is free to take any possible values. So it's a free variable, and that is something we don't want in a sentence. So this is an incorrect option. Now option D, this has for all x, but the rest of the formula, which is tall father Sneha, this formula doesn't even have a variable in it, right? So the question of that variable being in the scope or not doesn't even arise. Okay, this sentence basically says that for all variables x, father of Sneha is tall, right? If you have to think about it in terms of elaborating it, which will be true, right? So that is the difference between options A and D and option G. So let's look at it part by part. So first of all, alpha implications beta. For this to be a formula, alpha beta both have to be a formula, right? So this tall x, this is a formula we know. Tall father x, this is also a formula we know. So tall father x implies tall x. This whole thing is also a formula. This is also correct. Now this x is a variable, and this is also within the scope of this quantifier for all. That's why this is not a free variable, and this is also a proper formula. So this is a proper sentence of first order logic. Ariman, sorry, your voice is breaking. Can you come again? Can you repeat why B is incorrect? B, the second option. Yeah. The second one is correct. Yeah, let's go over why that is correct. Okay, so here we have tall father Sneha. Okay, so let's look at it part by part. So what is Sneha? Sneha is a constant symbol that is given to us. Okay, and a constant is a term that we saw in the definition of terms, right? If t belongs to constant, then t is a term. Okay, now what do we have over here? Now next we have father of Sneha. Father is a function symbol. Again, let's revisit our terms definition. F, where f is a n-place function symbol, f of t1 t2 up to tn, this is also a term. So in our case we only have function of one single t1, okay, which is basically father bracket Sneha. So that is also a term, okay. Now let's look at the definition of a formula or an atomic formula to help us, okay. This one said that a predicate of terms is also an atomic formula. Here what did we have? Tall of a term, father bracket Sneha is a term, right? So tall, which is a predicate of a term, is an atomic formula, right? Because this is an atomic formula, this is also a general formula. This does not contain any variable, so we are not worried about whether the variable is free or not. So both the conditions for a sentence are satisfied. It is a formula and it does not contain any free variable, so it is a sentence of first order logic. Does that help, Arima? Okay, that's great then.
Yes, sir. Actually, whether all well-formed formulas are sentences?
So that you have to see whether that well-formed formula is in. First of all, you have to check whether that is a proper formula or not, okay. So just by being a well-formed formula, it doesn't qualify to being an actual sentence, right? You have to check whether there is a variable, you have to check whether there is a free variable or not. There are multiple conditions that you have to check. Yeah, if it is not free, then you do. So if you have a variable that is not free, it is within the scope of a quantifier, and it is also a proper formula by the definition of a formula, okay. That definition of a formula in itself contains several steps, okay. Let's go back to the definition of a formula.
Can we treat all sentences as formulas, well-formed formulas?
No. A formula with no free variables, that is a sentence, okay. So there are formulas that have free variables, right? We cannot call them sentences. So you have to look at the definition step by step.
Okay, sir.
Yeah. See, don't okay. Don't try to make direct conclusions like if this is something, then that is that. In this particular example, it's always better to approach the problem step by step, okay. So think about whether a well-formed formula will be a sentence or not, okay. So for that, look at a definition of a sentence. What is the definition of sentence? It contains two parts: formula and no free variables. No free variables, you can check if there are variables or not, okay. Now formula, what is a formula? For that, go to the definition of a formula. Atomic formula is a formula, and two or more atomic formulas connected by connectives are general formulas. Then go back to the definition of atomic formulas, okay. What is an atomic formula? Then the well-formed formula part comes in, okay. So that's how you draw the connective connection between whether or not something is a sentence or not, okay.
Okay, clear.
Thank you. Thanks for your question. Okay, shall we move on to the next question then? Okay, so this asks us, this is the same similar setting. Father and coach are function symbols. Tall is a relation symbol or a predicate. Sneha is a constant symbol. Which of the following are sentences of first order logic with equality? Okay. So again, I'll let you go through the options one by one, and then we can have a discussion. Yeah, Yagesh. Thanks. Yeah, thanks for letting me know. Yeah, I was just back. I was just waiting and giving you guys a couple of minutes to go through the options. But yeah, we can start the discussion now. Okay, so let's look at the options one by one. So the first option says father of X equal to coach Sneha. Okay, so again remember, for it to be a sentence, okay, it has to be a formula. There have to be no free variables. Okay, again go back to the definition of formula, atomic formula in terms. Okay, so if you remember, we had seen in the definition of an atomic formula, if T1 and T2 are two terms and T1 equals to T2, that is also an atomic formula. Okay, now let's go back to the options we have. So coach Sneha, this seems to be fine, but father X, this has a free variable, right? So without any further thinking itself, we can say that option A is incorrect. What about options B, C, D, E, F and G? In each of these you will see that the left and right hand side of the equality, they are a term. Okay, and by definition, because both the left and right hand side of the equality are a term, the total thing along with the equality is also a term, is also an atomic formula, sorry, right? Because it is an atomic formula, it is also a general formula. Now the only thing that we have to check is whether or not there are free variables, right? So in B there are no variables, so of course we don't concern ourselves with whether there are free variables or not, so B is correct. In option C, we have a variable, but that is within the scope of this existential quantifier. So option C is correct. In option D, there is a variable associated with this existential quantifier, but that variable does not occur anywhere in the rest of the formula. So again, we are not concerned about it being free or not free. Okay, so this is also a proper sentence with equality. Similarly, option E is also a proper sentence with equality, because this also has variable which is quantified, which is within the scope of the existential quantifier. Okay, same holds true for options F and G. So for this question, except option A, all of the other options are correct. Okay, I'll let you go through these answers maybe for a minute or so to convince yourselves, and then we can move on to the next questions.
Sir, hello.
Yeah, Vijayshri, please.
Sir, can you please let me know like when can we consider the free variables and when not to consider the variables?
Yeah, so I guess your question is, when can we say that a variable is free or not, right?
Yes, yes.
Okay, so in that case, what you have to do is look at whether it is contained within the scope of a quantifier or not. Let's consider one of these options. Okay, let's consider the third option. Here we have a formula that says father of Sneha equals to coach of some person X, some variable X. Okay, so basically since this is an existential quantifier, what this means that there exists some person who is represented by a variable X, such that X is coach, and this is equal to the fact that father father of Sneha. Okay, so father of Sneha equals to coach of X. So this X is falling within the bounds of this quantifier, existential quantifier. Okay, as opposed to something that is not within the bounds is something like this option that we had seen. Okay, first of all, there is no quantifier itself over here. Okay,
Yeah.
and then this variable X, this is free to take any values. Okay, this can be infinite number of values. Okay, so this is a free variable.
Okay, sir.
Okay,
Thank you, sir.
thanks for your question. Yeah, that's great, Balaji. I was just replying to a message that he sent in the chat. um, okay then, if there are no further doubts on this one, maybe we can move on to the next question. So this is a question based on interpretation. Okay, so an interpretation I, okay, so this is just a fancy way of writing I, equals to domain and its interpretation I of LPFC. So basically an interpretation unambiguously determines the truth value of which of the following? So again, I'll let you think for a while and then we can discuss. Okay, so we already have a couple of answers in the chat, and I think most of you would have gotten it correctly. So the correct options in this case would be A and C. Okay, why? Because an interpretation can unambiguously determine the truth value of formulas with terms only from the sets F and C, which is formulas and constants. The second option says that formulas with terms made up of free variables and constants. Okay, so if a variable is free, then of course you cannot unambiguously determine this truth value, right? Because that variable is free to take any possible values. So it's not even possible for us to unambiguously determine the truth value of that formula. So just by looking at that, we can say option B is incorrect. Option D says, again mentions a free variable, right? So again we can say that option D is incorrect. Let's look at option C, formulas with terms made up of bound variables and constant. Okay, so now the variable is not free. Okay, so now we can look over all the possible values that the variable can take, and we can unambiguously determine the truth value of that formula. Okay, so the correct options would be A and C. Okay, is that clear? Shall we move on to the next question? Mm-hmm. See, so P is a predicate, right? So predicate, like we discussed before, is a subset, right? So you cannot really assign a truth value to a subset, right? You can assign truth value to a formula that may contain some instantiation of that thing. Okay, for example, let's say we have something like, for all x, tall x implies uh, something like anything randomly. Say tall x implies has pet x. Okay, so basically what this says, that for all variables x, okay, if x is tall, then that means that x has a pet. Okay, now this represents a set of things in your domain or universe of discourse. Okay, if that had a specific instantiation, then you could say, like, if you had something like tall Ram implies has pet ram, right? Then you can say whether this is true or false or not. Okay, am I making any sense, Ariman? Sorry, can you speak up a bit? Yeah, sure, let's go over it once more. So let's see what interpretation is. Okay, let's go back to the lecture slides. Okay, so an interpretation of a first order logic constitutes of a domain D and a mapping I from the language L to the domain D. Each of the elements of the sets P, F, C are interpreted over D. Each of them is understood or gets meaning from the domain D. Predicate symbols are mapped to relations on D, function symbols are mapped to functions on D, and constant symbols are mapped to individuals in D. Okay. So okay, this doesn't have specifically what we are looking for, but that's all right. Let's come back to our options over here. So an interpretation can unambiguously determine the truth value of a formula with terms only from the sets F and C. Okay, now I see where the issue might be happening. Let's go back to the definition of this thing. Okay, this seems to have confused me as well. Thanks for pointing that out, Aryaman. uh, okay, so let's discuss it. So based on what I understand, what this is trying to say is an interpretation unambiguously determines the truth value of formulas with terms only coming from the set of formulas and constants. The way I see it, if we have a predicate which represents a subset, um, we'll have to look at all possible values that can be put into an interpretation, right? And well, that can be called a formulas. That can be called a formula. Mm-hmm. Okay, let me think this a bit more and get back to you on this. Will that be okay, Arima? Yeah, but thanks for pointing that out. That's a valid point. And yeah, based on what you say, P should be a part of it. But yeah, like I said, I think more on it, and I'll come back to you. Maybe if not today, through the discussion forum or in the next live session. Okay. If I don't, just remind me. Okay. Thank you. Okay, but option C is clear, right? Okay. Okay, yeah, I'll think on it maybe later. I'll not take up your time. Let's move on to the next question for the time being. Okay, so this question asks us which of the following pairs of clauses are unifiable. Okay, so yeah, again I'll let you think for a while and then we can have a discussion. Okay, in the meantime, Ariman, are you still there? Yeah, I see you. Uh, so, before discussing the current question, the doubt about the interpretation question that can be answered through our lecture slides itself. Okay, so like we were seeing the definition of interpretations over here. If we just go a further bit into the details of um, the definition of interpretation, so here it says that for every predicate symbol q belonging to the set of predicates of arity n, interpretation of q is q of I, where q of I is the image of q and qi, okay, which is d into d into d. Okay, similarly for every function symbol f belongs to f of arity n, yeah, interpretation of f is an f of I, where f of I is the image of f, and fi is basically relation from or function from d times d times d times so on and so forth to d. Okay, and similarly for constant. Now when you go into the interpretation of terms, okay, terms in first order logic denote elements in the domain. Okay, a term mapped to the element of a domain D as follows. If term belongs to a variable, then the image of the term in A, okay, what is A over here? This is just an assignment. In addition, we have an assignment A, which is variables to the domain from the set of variables to the domain. Okay, so this is just representing an assignment. So the image of the term T with assignment A is just the assignment of A to the term. Okay, I know this sounds confusing, but if you just look at it, it makes sense. Okay, similarly for terms, all terms that are constants, the same definition follows. Okay, now if I go further down, truth assignment to atomic formulas. Okay, a valuation function value or val from f, which is a set of formulas, to true or false. Okay, this proceeds in this manner. Okay, so true is assigned, top is assigned true, bottom is assigned false, and so on and so forth, with corresponding assignments and in images. Okay, truth assignments to atomic formulas, truth assignment to formulas, truth assignment to quantified formulas, truth assignment to sentences. So here, as of now, I don't see any mention of a truth assignment to a predicate. Okay, so I suppose that is why their predicate was not mentioned among the options. But okay, like I said, I'll maybe think a bit more about it, try to see if this can be narrowed down to a more simpler version of the explanation, and I'll get back to you again. But yeah, for the time being, we'll have to deal with this complicated interpretation or explanation. Is that all right? Okay, cool. All right, coming back to this question about unifiability. So yeah, what do you think? Okay, so basically, what is unification? Okay, if you have seen the lecture videos, you would remember that a unifier or a substitution theta is a set of variable and value pairs, each denoting the value to be substituted for the variable. Okay, this is a formal definition. I won't go into the details of it. I'll instead show you an example. Okay, so modified modus ponens. Okay, this is something that you may have come across in the lecture videos. Basically what this says is, so normal modus ponens you remember, right? If P implies Q and P is given to us, then we can conclude that Q is true. Okay, now suppose you are given this thing, a universal instantiation of this particular formula, right? P of question mark X implies Q of question mark X. This basically means that for all X, Px implies Qx. Okay, this is basically what it says. And you are given P of A is true. Okay, you are not given for all X, Px is true. Okay, so what you can do is you can do a substitution over here. You can substitute this variable X to take the value A, and then you can say that Q of A is true, and that is what is modified modus ponens. So basically this is saving you a step, saving you two steps. Okay, so instead of first saying that instead of having two steps, okay, of first looking at whether PA is true or not, and then substituting PA as X as A, and then further deducing using modus ponens, what modified modus ponens does is that it does a substitution using this theta, where it substitutes X with A and directly concludes Q of A. Okay, so this is an example of substitution. So here you have to do something similar, but the catch is you have to remember the rules of unification. For that, let us go to the unification algorithm. The unification algorithm tells us that we take two or more formulas and find the most general unifier. Okay, remember that two constants can only match or unify if they are identical. This is one thing you have to remember. Two lists are unified element by element, building up the substitution as we scan the lists. This is the second thing that you have to remember. And the third thing you have to remember is a variable can match another variable or a constant or a list not containing the variable. Okay, so these are the three things that you have to remember. Now coming back to the question or the options that we had. Okay, so the first option we have not likes question mark Z1 Anisa. Okay, do we have can we unify this with this? So based on the rules of unification that we just saw, what do you think? Just this first option, option A over here. Any guesses?
In the first one, it is Anisa is a constant. Constant has to match with the constant. But the second need not be the same constant. Maybe option A is wrong.
Okay, let's check. It is in fact correct. We can only replace or substitute a constant with a constant if it is identical, right? So the option A is incorrect. What about option B?
Option B is correct actually, because both are constant and the first one is variable, right?
That's right. So option B will be correct because Anisa can be substituted for Anisa. Okay, this is a constant, this is a constant, and Z1 and Z2 can be substituted, because remember a variable can be substituted if what is being substituted with that itself does not contain the variable, right? So if this had been Z1, then we wouldn't have been able to unify it. Okay, if both had been Z1 or Z2, then we wouldn't have been able to unify it. But since this is z1 and z2, we can do the unification and say that option B is correct. Okay. What about option C?
If we can match a variable with a list, whether it is also true.
So let's go back to the definition. A variable can match another variable or a constant or a list not containing that variable. Okay, so by this definition, we can, right? We can replace, we can substitute x1 and mother z2. Okay, and we can obviously substitute z1 and z2. So option C is also correct. What about option D? We can replace z1 and z2. Can we replace x1 with mother Anisa?
No, we can't. Mother Anisa is a constant.
See, we can do that over here because mother Anisa is a function over here, right? Mother is a function. See, starting with a small letter. Here it says that a variable can match another variable or a constant or a list not containing the variable. And we have mother Anisa over here. Anisa is a constant.
Yes.
Okay. So the correct options are B, C, and D. Alright, so shall we move on to the next question? Okay, option D, let's go over once more. So here the question is, okay, let's look at the two variables that we have. We have z1 and x1. Okay, can z1 be substituted with z2? It can be, right? Can x1 be replaced with mother of Anisa? It can be, right? Because by definition a variable can match another variable, which is not true in our case, a constant, which is true in our case, right? Because Anisa is a constant, so mother of Anisa is also a constant, right? Do you agree with me?
Yes.
Okay.
Sir,
Mm-hmm.
first question A.
Mm-hmm.
Whatever is the right side, to the left side, whatever is the left side, to the right,
Mm-hmm.
will it be okay or not?
Okay, let's think about that. So, in that case, if we reverse the order, we would have likes z2, mother z2, and on the other side, you will have likes, not likes z1, Anisa. Okay, so in that case, mother z2, yeah, then it would be very similar to D. And I think in that case, we will be able to unify it. Right, because z2 can be replaced by z1 and then but you have to check whether a variable can be substituted with multiple things at a time. Okay, so on one hand you are saying that z2 will be replaced by z1, but on the other hand you are also saying that z2 will be replaced by, or mother z2 will be replaced by Anisa. Okay, so if that can hold, then you can say that it is unifiable, otherwise it won't be.
So when you say where process,
Mm-hmm.
shift the order, it is not unifiable, or is there a
So here we are looking at substitution of something by something, right? So here what you're trying to do is,
any way
yeah.
shuffle the page
Mm-hmm.
left side, it should have the same property as far as unified is
Right, so your confusion is valid, but you have to think about what you are substituting with what, right? So if you are trying to substitute a constant, then that has to be substituted by an identical constant, right? If you are trying to substitute a variable, that can be substituted by a number of other things that is mentioned in the definition of whatever that is the unification formula that we saw. Here, if you are reversing this order, okay, that is not one pair that we are talking about, okay. The order of the order that is changing is what is being substituted by what. That is why whether a thing is unifiable or not, that is changing. Am I able to get across my point?
Somewhat.
Okay, so maybe let's think about it for a while, and hopefully that will help. If I have to give a further bit more clarification, see here our substitution was x was being substituted by a, okay. If this had been third bracket a comma question mark x, do you think would that have been valid? No, right? Because for a to be substituted, it has to be substituted with a itself. Okay, and also that doesn't make sense. You cannot assign a constant another variable, right? So that is that point that I'm trying to convey. Exactly. What Smarak is saying in the chat, a variable can match a constant, but we cannot assign a constant another variable, right? That is against what the point of that point, the point that we're trying to make, right? A variable is a variable because it can take multiple varying values. So one of the values that it can take is also a constant, but assigning a constant a variable is counterintuitive, right? Okay, that's great then. And by the way, thanks for all these questions. I think these are helpful to others and myself as well. Uh, I also have not been in constant touch of these topics, so sometimes it's a good refresher when you ask these questions. Okay. Yeah, Ariman, please go ahead. Oh, so you are referring to option B, is it? Okay. Let's do one thing. Let's write that down. Maybe that will be helpful. So we have not likes. I'm not writing the whole thing. Not likes. Question mark. Z1 comma Anisa. Okay, again I'm not writing the whole thing. And on the other hand, we have likes Z2 question mark Z2 Anisa. What you're asking is if we reverse this order. Am I getting it right, Ariman? And you want to unify it with the same thing, or do you want to change this as well? Okay. Okay, in the place of Z2 you want Anisa. Okay, so let's erase this. So here you have Anisa, and here you have Z2. So this seems unifiable, right? Because here you have Anisa that can be matched with Anisa, and you have Z1 which can be matched with Z2. Anisha and Anisha. Okay. So instead of Z2, you want to have Anisha. Mm-hmm. So this is the setting you are referring to, is it? Anisha, comma Z1 and Anisha, comma Anisha. Yeah, this also seems to make sense, right? Anisha you can match with Anisha, and Z1 also you can match with Anisha. Okay. Yeah. Thanks for your question. Okay then. I hope this discussion was fruitful. Uh, we can hopefully move on to the next question now, which is something that we already discussed. Okay, but still, let's go over it. Modified modus ponens rule combines which of the two rules of inference? So we just discussed this. Should be easy. Which option do you think would be correct? C, that is correct. The correct option would be modus ponens and universal instantiation. That's right. So this was straightforward. Let's move on to question 10 then. Now we are concerned with a Skolem constant. So a Skolem constant is which of the following? Okay, again a definition based question. So what do you think? Okay, so we have a couple of answers. Let's go through them one at a time. So, or maybe first let's look at a Skolem constant over here. That will clarify some things maybe. Aha. So Skolemization. When the existential quantifier is not in the scope of any universal quantifier, then the variable it quantifies can be replaced by a Skolem constant. Okay. Now, what about function? When the existential quantifier is in the scope of one or more universal quantifiers, then the existentially quantified variable is a Skolem function of the corresponding universally quantified variables. With this definition in mind, let's go back. This question asked us about a Skolem constant. Okay, so this Skolem constant is like a constant of LPFC because it maps to a fixed element in the domain D. That is correct, right? We just saw that. Is different from a constant of LPFC because it is universally quantified. This is incorrect. Sorry about that. This is incorrect because we saw that a Skolem constant has to be not within the scope of a universal quantifier, right? When the existential quantifier is not in the scope of any universal quantifier, then it can be replaced by a Skolem constant. So option B cannot be true because it is different from a constant. That is basically it is not universally quantified, is what I am trying to convey. The third option says it's like a variable of FOL since the mapping to an element of the domain is not specified. This is also true. Option D is also true because it is different from a variable as its value cannot be determined by making an inference. Okay, so the correct options are A, C and D. Any doubts on that? Right. So if I have to again go back to the lecture videos or the lecture slides, so here one example was, suppose exists z, okay, this is z is an existential quantifier, okay, and this is and student z, bride z, there exists z, student z and bride z, okay. This z is not in the scope of any universal quantifier, so we are replacing this z with this sk1 over here, which is column constant 1. This 1 is randomly assigned, okay, this not doesn't have to be 1, this can be sk2, sk3, sk300, whatever, okay. So here we are removing this there exists z part, and we are writing student sk1 and bride sk1. Now what does option C say? This column constant is like a variable of FOL, since the mapping to an element of the domain is not specified, right? Here we are replacing z with sk1, but still the mapping is not specified, right? This z can refer to anything, this sk1 can also refer to anything. That is why option C is correct. So it is like a variable of FOL in those terms, but it is also different from a variable, which is what option D tells us. A column constant is different from a variable, as its value cannot be determined by making an inference. Okay.
Yes, sir. Thank you.
Okay. Thanks for your question. All right then. Should we move on to the next question then? Cool, let's do that. So this question asks us about a scolem function. A variable x is substituted with a scolem function of variable y, then this means which of the following? So remember the definition of scolem function we just saw, and based on that, what do you think will be the correct options? Remember, a scolem function only replaces something that is existentially quantified and that is in the scope of a universal quantifier. So I'm giving you a hint over here.
So option
Yeah, I'll just go over the hint once more. A scolem function replaces an existentially quantified variable which is in the scope of a universal quantifier.
option C.
That's correct. Option C is correct, and in fact that is the only correct option in this case. Okay. This is also a pretty straightforward question, straight from the definition. So if that is clear, that brings us to an end of the questions from week 4 that we were supposed to discuss today. And before asking if there are any other things, I would like to ask one particular thing that was raised in the previous live session. So Aryaman, if I remember, you had asked some doubts from the week 0 assignments. Were you able to get a chance to go through the videos, the video where we had discussed those questions? Do you still have any doubts on them? If so, we can discuss them today. Otherwise, it's fine. Aryaman, are you there? Okay, no worries, no worries. Yeah, take your time. If there are any doubts, please let me know. Uh, yeah, Yogesh.
I am unable to understand that symbols and significance whenever I am going through the flow
Mm-hmm.
and reading it. I am getting confused many times.
That is understandable, Yogesh. Even I went through that when I first did the course, but I would say just keep at it. Okay. What I can suggest is maybe try making notes of it. Okay. So when you see something in the videos, try writing it side first. Try to listen to what is being said in the lecture recordings that Professor Khemani is doing. Right. Then try to understand what is being said. Okay. You don't have to completely understand it. Whatever you understand, try writing it down yourself in your own words. Okay. Then again watch it and see whether what was being said over there is matching what you have written. Okay. So if you keep doing that again and again, that will help you understand, help you resolve the confusion with the symbols that you are referring to. And if you still have any doubt, any specific doubt, then you can always post it in the discussion forum and Bhaskar and sir will be addressing it.
Okay, sir.
Yeah, I hope that helps.
So just one doubt.
Mm-hmm.
Multiple formula can contain only of the connectives in binary.
No,
No?
no, we just saw that, right? It cannot contain any connectives.
Unary connectives, Yogesh?
No, if you have something like unary connective, right? So basically, what is the essence of an atomic formula? It cannot be further broken down, right? So if you have something like negation of negation of negation of negation of negation of negation of something, will this be an atomic formula?
Okay, it can be decomposed.
Exactly, it can be decomposed, right? So we cannot call it an atomic formula.
Sir, what about the same thing in well-formed formula and sentence? Four negations or even negations. Say odd negations is even it's the same.
See, see, there are two things. One is whether it is a well-formed formula. Another thing is whether it is a sentence. Whether it is a well-formed formula or not, that for that you have to look at the structure or the syntax of the formula. If that is proper, then you can say it is a well-formed formula. Whether it is a
Because I've never seen like four odds like 4, 6, 7, even odds even
that's okay. Yeah, that's okay. As long as it is make, uh,
even
and yeah,
A, yeah, A
then
and even A will be the same as A.
yeah. See, the number of negations doesn't matter as long as it is making sense. Okay, if you had something like A and or B, this is not a well formed
No, A and not A is not invalid because A and not A is equal false.
no, no, no.
And or false.
See, don't confuse yourself with whether something is true or false. Okay, when you're looking at a well formed formula, see whether the structure is proper or not. Where what truth value it arrives at, that is a later concern for you. Okay. Let's look at it. Okay, let's look at what a well formed formula is. So, a well-formed formula is an expression consisting of variables, parentheses, and connective symbols. Okay, as long as it makes sense, you don't have to worry about whether what the truth value of it is. Okay, okay, and whether it is a sentence or not, that is a whole other question. Sorry, for that you have to again. No. For sentence, you don't need to see the truth value. For sentence, you need to see whether it is a formula and whether it contains any free variable.
First we should check whether it's a well-formed formula for sentence. Then we should check
Whether it is a formula or not.
that is exactly.
Whether it contains a free variable or not. So remember, don't confuse well-formed formula with the generalized formula that I was referring to. Okay. when I say formula, I refer to the definition that is given in the lecture slides that has a number of steps to it.
You see that sentence, first it should be a very formula.
It should be a formula.
Yeah. Second is that
Whether it contains a free variable or not. Okay.
variable like X, Y, Z or not.
Yes.
So if it contains a free variable, then it's formula.
Yes.
And the third is it can have like symbols like and or right multiple
That I'll let you answer, because can a formula contain and or implication? What do you think?
yeah formula can contain.
Then can a sentence contain it?
Yes.
Then you have answered your question. Okay. Okay. So in the meantime, Balaji has mentioned something in the chat. Aha, right. So I think someone had also sent this. Maybe Varun. Varun, you only had sent something about this in the discussion forum.
Yeah, I had sent.
Yeah, so I think that has also been answered by Bhaskaran sir. You can refer to his explanation as well. So this basically refers to a null set, right? It doesn't contain anything.
I know what is a null set. Yeah, I forgot to ask you. Like I know what is a null set, but I knew what null means. So I mean, when you said null set, like yeah, valid or null. Because null I know what is like.
Mm-hmm.
Right side null, left side null. That's basic.
Okay.
So if the right side is null, then obviously it's true. Right? For example, first option then true, second option is true, the third option will be true. Correct. Second option is true. Right?
Okay. So what are these referring to first of all? So P of x comma y. What is P over here? Is it a predicate? Are you referring to? What is P? Can you hear me? Okay. P of x comma y implies Q of a b c. Okay. What is Q here? Okay. And x, y, a, b, and c. What are all these? They're all constants. Okay. Okay. So what is the thing that you want to answer over here? Yeah, yeah. But so you're given me three facts. So what do you want to ask through these examples? Like, okay. See, if x, y, a, b, c are all constants, then this just depends on your domain and what this rule is trying to convey, right? I'm still confused about what you mean by whether it is true or false. So okay, where did this doubt originate? Can you tell me that? Sorry. Okay, so so that you should have told me before, right? So since this is an assignment question, I okay. 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 So what I would recommend is, since I am not exactly okay, what is the meaning of empty second brackets? That is what you want to understand, right? Mm-hmm. Uh-huh. Okay,
try to
so
understand the simple null area.
mhm. So I'll take an example that you have mentioned in the discussion forum and just explain what I can explain. Okay. So here you have something like tall equals to Ada comma Ben. Okay. Likes equal to empty. And here you have a something that's a rule that is given to you for all x. Tall x implies likes x comma Ada. Okay. Now you have what this option 2 is telling you is that x can take values Ada and Ben, okay, for this tall predicate, but this likes cannot take any proper pairs of values is what this option is trying to convey.
Since it's given for all x, so the tall of x, so like Ada and Ben should be their likes. So Ada and Ben should be their let's say for when sum is given, it can be there one Ada and Ben or Ben. One of them can be.
Mm-hmm.
Yeah.
You want to ask whether these options are true or not.
No, no, yeah, this.
Okay.
All of Ada Ben. Consider the first option.
Mm-hmm.
First option is called as
Mm-hmm.
Ada and Ben.
Mm-hmm.
Saying Ada and Ben both of them can be
Mm-hmm. See, what it says it for all x. Okay, so what are the values that x can take? You have to substitute it one by one, and then you have to use this implication to arrive at a conclusion. And if that is contained in this set of likes, then you say whether that is true or not. Okay, this is the maximum that I can help you with this. Okay. Okay. Yeah, that's what I was telling you, that you have to look at the possible values that x can take, okay, then arrive at the substitute it one by one to that variable, and then arrive at a conclusion using this implication that is given to you. Whatever conclusions that you could arrive at using all possible values that x can take, because you have a for all over here, if that is contained in your likes set over there, then based on that you decide whether that option is correct or incorrect. Okay, that's the maximum I can give you.
I think I'm getting confused. When the x side has null, which side is also null?
No, you don't have to confuse about which side has null. That is pretty clear. If likes equals to null, then likes is null. If tall equals to null, then tall is null.
No, no. That means when you use the formula for all x, it is given null is also null.
That's what you have to decide, right? Can that be possible? Okay.
And the one more thing,
Uh-huh.
friend, like the likes example,
Mm-hmm.
take
Mm-hmm.
example.
Mm-hmm.
Take likes x y since it has likes yx or friends. In example, when it says friend of the friend one friend that you said, if x is a friend of friend, y is also a friend of x. Friend x y is equal to friend of x.
Should be, but I would encourage you to check it with the lecture slides or the book. Okay, just verify it once. I think it should be, but still verify it once.
The brother or sister is not clear to understand. X is a brother of y.
Yeah.
Yes, y is a sister of y. It can be like that.
Yeah, depends on the way you define it. Yeah. That's
See,
yeah, that's a good point. That's why I would encourage you check it with the book once. Maybe it won't be explicitly answered in the lecture slides.
it's not in the book.
Uh-huh, yeah. So that case, you can check it with the book. If it's not present in the book, then I can also look it up, or you can also post it in the discussion forum. So either I can or Bhaskar and sir can address it over there.
Sir, whatever answer Bhaskar sir is given,
Mm-hmm.
I could not get head and tail of it. Just some notes he has given. Reading all these things, one can
So, s-
we are not understanding where today, I think you would have done a good job of listing all possibility.
mhm.
Nobody is helping, just saying that go to book, go and then see the logic. This is not helping us. I'm
See,
very honest.
I
It is
appreciate
not there.
you.
It is not there in the lecture notes. It is not there in the books.
See, I appreciate you telling that, and I appreciate you addressing that. I would also encourage you also write this exact thing that you have said as a reply over there. It should be visible to all. See, but the ultimate point of all these things is that you have to understand and you have to solve it on your own, right? If all of us always keep answering every doubt, then it will be akin to spoon feeding, right? So it's okay to get things wrong once in a while, okay? It doesn't matter, as long as though that getting that thing wrong helps you understand it at a later stage, that's fine. Okay, so like I said.
I'm sorry to say that this is not spoon feeding what we are doing for answer everything. This is a concept. This early brackets are there, right side and left side.
Mm-hmm.
Go through Wikipedia and other things. What
Mm-hmm.
it says is the null set means
Mm-hmm.
some word they use. I just explain. When you, what is that? Duopolistic truth. So, for example, I am a parent and say I don't have notes as my children. When I don't have any children, that is true in sense. All my
Okay.
students are notes, if I may say. Then, if I don't have any children, then that is true according to logic. That is really confusing.
So why don't you do one thing? Okay. So like Varun has posted a question over here. Okay. Varun, I would give this task to you. What, based on whatever you have understood, and even Balaji to you as well.
Even I got confused.
I understand that, but what I'm trying to do is trying to get this resolved both from your and Bhaskaran sir's end. Okay, so what I would suggest, both Varun and Balaji or anyone who wants to attempt these two questions, you write down a solution as well, not just the question, your attempted solution. It may be incorrect, it may be correct.
Yeah, but I'm clearly confused. Weak answers.
Sorry.
This was weak assessment.
Right, that's okay. So you write your thinking process. If it's for the current assignment, you write your thinking process, and then specifically tell whether this thinking ask whether this thinking process is correct or not. Okay, and I will also convey this information, whatever I feedback I have gotten from you and Balaji, I will convey this to both Bhaskaran sir and Professor Deepak Khemani, and then let's see whether it gets resolved or not. Okay.
Sir, actually,
Yeah.
I have a question. Since this is mostly containing logical reasoning,
Mm-hmm.
but I experience is lack of sufficient examples in the lecture materials.
Yes, sir.
That's
Even I feel that examples should be given. The sequence should be very clear. When we read
because,
the
sir,
essay,
definitions are actually given. Okay, that is correct. And the definitions are very standard definitions, like with the proper suffix, prefix, identities, and everything will be there.
Uh-huh.
And if one or two examples or sufficiently additional written materials are uploaded along with the books, then it will be helpful, because those type of questions asked for the assignments were not actually explained during the lecture session, and we have to at least wait for this problem solving sessions to interact with our faculties, right? Or like this only sessions.
Mm-hmm.
And this is only a 2 hour session, and everybody can't interact very like well in this 2 hour session, because it is a time up.
Yeah.
I can understand, because 2 hours is very lengthy.
Mm-hmm.
And actually, if sufficient examples were given along with the logical reasoning, because logical reasoning is always confusing.
I
If
understand.
one or two examples are there, then we can have a clear idea. Because even if we do the same problem, maybe it is a chance that if we
I agree.
But I am raising.
Yeah, I agree with you. So I think this issue had arisen even in the previous year, and this had been conveyed from my side. But so I remember there were some assignments for which some practice assignments are being uploaded. So does this week have any practice assignment? Is what I.
Practice assignments were there actually, but they are too simple. Like, okay, without watching also, maybe we can do that. And they are
Okay.
completely different from the week assignments. Okay, that's what I experienced. No, I'm not asking for any answer or nothing like that.
Mm-hmm.
I'm just
I
looking
get that.
for guidance to solve the assignments. Otherwise, there is no point in paying the fee and writing the examination and getting a knowledge. Anyway, logical reasoning is a foundation, right? Predicate logic also.
Mm-hmm.
And of course, you may be knowing predicate logic is quite confusing.
I fully agree with that.
Yeah, that's what we need some proper examples.
Okay, so see, unfortunately, the only thing in my hand is to convey this information to the main team. See, because my responsibility, I'll be very honest and very blunt about it. My responsibility through these live sessions is only to solve some sample questions that are already existing in previous year assignments. Okay, other than that, I have other duties to fulfill, but that are not concerned with these live sessions. But as far as these live sessions are concerned, my only responsibility is to convey and solve some practice questions that have been present in the previous year assignments. Any modification to the course structure or the assignment structure, or addition of examples, or addition of more practice assignments that are more similar to the assignment question that you are solving, all those queries unfortunately are not in my hand. They have to be transferred to Professor Deepak Khemani, Bhaskaran sir, and the main NPTEL team. So what I can tell you, and I'm saying this on record, I will convey this information precisely to them. Okay, and I would also encourage you to write about this as much as possible on the discussion forum. That's the only solution that I can tell from my side, unfortunately.
Okay, sir, I agree. Okay, your part is you are doing it very excellently. Thank you.
Yeah,
I really appreciate your contribution.
thank you.
But actually, I have done last year also some, last semester also some online course, NDTL courses like
Mm-hmm.
this machine learning and deep learning and all.
Okay.
But those were like the previous year and assignment and sufficient examples focus on the sessions were really good for the assignments and examination also. But for
Mm-hmm.
this subject, I am not getting that. Okay, that is why, okay, as a mediator, our request is please convey our feedback to the team, and we really appreciate your contribution. Thank you, sir.
No, thank you for saying that as well. I also appreciate you attending these sessions. Otherwise, it wouldn't be of any sense or use to me as well, right? But yeah, as I said, the maximum I can do is convey these to the main team. What I can do besides this is maybe try to look for some other possible questions, but then that is also difficult for me, right? Because see, I am also a PhD student, like some of you guys might be, so I have other responsibilities as well. I can try and add some more questions that might be more similar to the current assignments, but yeah, I cannot 100% guarantee that I will be able to do that in all weeks for all topics, is what I can say.
Ethics, Amal sir, you
Yeah.
have done a great job so far. No doubt in it. In my life, I have read something called James Maxwell's equation
Mm-hmm.
in physics, and it was very, very tough. But if you had a chance, you wanted to kill him because he developed those equations. The next toughest thing that I have seen in this course, therefore I'm calling this course, enjoying it, happy with this one. I am really struggling to understand what is this.
I I appreciate you saying that honestly, and this is all on record. So anyone who has access to this videos will be able to hear this. I hope the NPTEL team also hears it, and I will convey this from my side as well.
Thank you. Thank you.
Okay. So Thank you. Yeah, but so we are ending the our near closing time. So we have to close the session now. But yeah, I will convey these points and let's meet next week again. Okay.
Thank you.
Thank
Thank you,
you.
sir.
Thanks for attending and thanks for all the already all the points that you have raised.